Well, welcome everyone in person. It's great to see all of you and the people online who I can't see. This is the 2025 AI East Bay Lecture Series, Consultants' Role in Architecture. And my name is Brian Stryzik. I am an architect at Kennelly Architecture and Planning, but I was also the AI East Bay Board President in 2022. Since leaving the board, I've been working on this lecture series and really trying to have the chapter have a forum to talk about design. We've looked at several different topics throughout the years. First year was looking at the legacy of the East Bay. Last year was talking about owner-architect relationships. And this year we're talking about relationships with consultants and architects. So we've had over 50 presenters in the last 2 years. So we've had really great discussions and dialogue. And based on the first two events this year, I'm anticipating this one being equally as good and engaging. So tonight's topic is green energy, which sounds pretty exciting. It's like an energy drink or a superhero. So I'm excited about that. But the subtopic is designing the future collaborative strategies for sustainable and innovative architecture. So we'll just say green energy. I think that one's much nicer. Each participant will share a 5-minute presentation to introduce themselves, understand what they're interested in, and get some viewpoints on green energy. And then we'll go into a moderated discussion. And please, since this is an intimate crowd, please ask questions as they come to you, and I'll try to get them in and kind of fill them in there. And okay, so we have 4 people here today, and including myself. We're going to start with the design consultants. Dan Johnson is co-founder of Streamline Green Inc. Sharon Block is the founder of Bright Green Strategies. And then representing the architect side, we have Seth Dunn, the founding partner of Praxis Architecture. And finally, Katie Ackerley, principal and sustainable design director at David Baker Architects. So interestingly, my birthday is at the end of the month, so I need to get my net zero or hours. And I ran across one of your panels that you were moderating. And you said that you were an environmentalist, and it asked if you're an architect, what your role was.
To me?
Yeah. Was that just kind of, is that true? Is that what your first passion is? And then you just happen to work at an architect office?
That's a good question. I think that is true. I think I said that probably in the context of these kind of identities we have professionally and the perspectives that those identities bring to the work, and that kind of environmentalists come with a kind of bias, like especially like green building people. And so that's something that I've kind of been interested to explore and examine as I focus really on a practice that's like public interest and it's like social interest driven. We do pretty much exclusively housing and community oriented projects.
How about you three? You feel like architects, consultants are environmentalists at hearts and secondary trying to find a way to engage people through what we're doing?
Yeah, I think I came through to this profession through being an environmentalist and coming into a career that could really touch on so many different points of things that actually matter and shaping our built environment. I just saw how we were building, how buildings were so destructive to our environment and producing so much waste, and I wanted to be inside of the machine that was making that happen.
Yeah, I mean, it's like, it's scary these days to say I'm an environmentalist, but I think, yeah, at the heart of it, I mean, for sure, that's where I'm coming from. And I think it's even more important, as we go into the future. I mean, I've been around for a while, so so I see, I've seen, things over maybe like 30 some years now. And so it's even more important. And I think, we have a lot of work to do, but you know, and that's why I think we're here tonight, is to inspire you and hopefully keep everyone going.
I came to architecture actually as a biologist and then from working on cars and doing a lot of crafts. So mechanical design and architecture seem to be a good fit and way to make a living.
Absolutely. All right, I can start a few questions before we get to the presentations, or comments at least. So green energy refers to energy that comes from natural sources that are renewable and non-polluting. These sources produce little or no harmful emissions and help fight climate change. So talking about the administration, I'm going to read a quote by President Obama. You don't have to share my passion for fighting climate change. A lot of Americans are going slower and becoming energy efficient, not because they are tree huggers, although trees, you know, are important, but because they're cost cutters. They're saving money. And I'm all for consumers saving money because that means they can spend it on other stuff. Solar isn't just for green crowd. It's not just for the green crowd anymore. It is for green eyeshadow crowd too. So Barack Obama had a lot more laughter during that one than I wrote. But yeah, that's good. Thank you. So what does green energy mean to all of you? And you know, is the dialogue shifting in the last 10 years? This was a quote from 2015, so 10 years ago.
Yeah, want me to take that? For me, it's been a lot of things, but right now it's about getting rid of fossil fuel. So the renewable energies that we're left with have certain characteristics, and we need to match those characteristics with our needs and our uses. And that creates exciting opportunities for architecture.
Yeah, so I mean, from my perspective, I mean, I've been involved in so I was an energy modeler, and then I also studied mechanical design, and now I'm basically a green building consultant, but we do energy modeling. But I used to have contracts with the Energy Commission, and we would do training to the building departments, and so I've seen like this shift from like our energy code, for example, really came out of the 70s, you know, during the oil embargo. And so it's just interesting to see the emphasis at that time was to all our energy codes were revolving around gas and fossil fuels. Like that was the preferred energy source. And now we've done this 180-degree you know, shift. I mean, when we need to, but to see like, you know, this shift from, you know, just what, you know, 30, 40 years ago to now, you know, we've really got to rapidly make this shift. I mean, so it's, I mean, I'm happy to see it happen, but it's just like, that's like where we were coming from. And now, yeah, like you said, we have to get rid of the gas or the fossil fuels and you know, go to a clean energy future.
Gotta say, I miss the lofty green of 10 years ago. We're all idealistic and we were all really trying to, we had a lot of vision and we're in the implementation phase now. And I think that's a lot harder to figure out how to do it and what are the trade-offs and what are the benefits. And for the last 10 years, we were really focusing on, you know, EUI as a metric, for instance. We were really trying to hone that into the architectural lexicon. And now we're starting to realize, oh, maybe that's not the best metric anymore. What are some of the new ways that we can think about grid interconnectivity and demand response and all these things? So I think the landscape's getting a lot more complex, and it takes a green energy consultant to really help navigate that.
Yeah, I think Dan said it well. It's that matching sort of alignment of your needs with the resources that you have so that you're not relying on something that in the long run just won't it won't last. And before I went to architecture school, I started my career at an energy efficiency advocacy company, and I just, you know, it includes energy efficiency as a resource. You know, coming into that job, I thought of green energy as the sources, right? The PV and the geothermal and energy efficiency, learning that that was a resource was kind of a big idea at the time. And so it really is that whole package of levers that the designers control that sort of, put together dynamically. And yeah, it gets, into a lot of dimensions really quickly. We'll dig into that more today, I think.
To follow up on this, like we're all California architects, we're all practicing here. It's a different environment here than other places. I know David Baker, now you guys have Alabama as an office.
We do, yes.
And you're starting to do work there. Is it,
Different.
are you different? There you go.
Yes.
And Sharon, are you exclusively, Hey.
Well, we work with someone out of Canada because we're also a lead for home provider. So we work with other like lead green raiders in other areas. We have one project in Turkey. So, yeah, so, but for the most part, we're in California.
Okay. I'll stick with that. It's different. I'm gonna pass over to him to just continue on some presentation.
Okay, thanks. How's the sound? Okay, good. Well, thanks. I'm gonna read from some notes so I don't ramble. Hopefully this will work well. So I want to continue talking about green energy. It's changed over the past decade, and this is going to focus on residential architecture. It's our main thing that we consult on. So we mentioned it already that today green energy means gas-free. And so we want to remove this poison that's been doing the most harm and go fully electric. The concept of net zero, I think is outdated. It's a relic of the early 2000s that doesn't really fit today's situation anymore. I'm just going to throw out a bunch of ideas here as food for our follow-up conversation. So I'll keep moving. But the shift now is that green energy arrives in cycles. It's not there all the time. Clean energy is cyclical, but it's predictable. So the sun rises every day, but electricity is precious after dark and during winter. So in California, as opposed to other parts of the country, our situation, we have this huge midday solar surplus. I'm sorry, the webinar thing is hiding my slide numbers, but I'll adapt here. Okay, we might be a little out of sync. Okay, so syncing up with these cycles of the natural availability of these clean energy sources creates challenges that should be form givers for architecture. For example, in the summer, buildings still need cooling after the sun has set. So where do you get solar electricity for that? Architecture can do some work there. In the winter, the heating needs are highest when we have the darkest days. So this is why in California, any building that's powered by green energy needs to be designed for load shifting. So Katie's going to talk more about that. But think of the load shifting or load shift as how we power a smartphone. You charge it up once a day, ideally, when there's power available, and then it slowly discharges, and then you repeat the cycle. So this is also how agriculture works. When we store the sun's energy when it's abundant, and then we use it later. So we kind of breathe in when there's a surplus, charge, and breathe out and discharge. So this natural rhythm is the model for how buildings can use green energy. And it doesn't need technology. Technology can be a distraction. So consider windows. Having better glass often leads to more glass area. So this increases energy demand. And I think we should acknowledge where we are with all the technology we have today. Our buildings are using more energy than ever before in human history. So what can we do? I want to recommend two practices that we'll talk about. Number one, refocus on fundamentals. And by this, I mean climate responsive orientation and massing, the stuff that's been in textbooks for decades. We don't need to reinvent the wheel. We have this really good wheel that we are often not using. Number two is the low-hanging fruit here is in the follow through. So this means delivering higher quality on what we're already doing, especially residential HVAC. It consistently does not meet code. So there's a big area there for engaging with tradespeople. So those are my two themes. And neither of these practices require high-tech solutions or new design tools. So what are the barriers? I think the biggest barriers are cultural and personal. We're asking people here to change the practices that they're most comfortable with, and to do things they've never done before. So this is personal change rather than technology, requiring a different set of skills. Green energy also means rethinking material. So it's not just about operating energy. We're reconsidering the fossil fuels that go into the building materials themselves. We want materials that are grown, not mined. So agricultural products and not industrial products. And the surprising part, low energy buildings are not less capable buildings. They're usually more capable. So let's consider lower energy intensity is correlated with greater well-being. In this photo, look at all the satisfaction generated by this minimal bit of architecture, and look how it's attracting people to it. So high energy intensity spaces, on the other hand, tend to correlate with stress and unhappiness. So think about it. Where do we go to relax? The places we seek out for vacation, recreation, relaxation are nearly always more low powered than our regular everyday lives. And it's like we're even forced to live in these energy intensive settings against our will. So it's a luxury to disconnect, to ditch the phone, the laptop, to use hand tools, to slow down. But we can normalize places like this in our architecture. We can create these low energy environments that don't need much power, and people will be happier in them. So some new technologies are essential, yes, like PV and battery has a place, but we don't get to well-being through technology. So that instead, the strong fundamentals of climate-oriented design and follow-through can reduce the demand for fuels and increase people's quality of life. So I'll talk about how we consult with architects. In our multifamily work, we do Title 24 and green certification. But the key is not just collaborating, but also knitting the team together. So we know a little bit about each topic. Our goal is to support the architect's vision for sustainability by finding a path through the codes and systems that let the team get to what they're trying to do with more confidence, do something new with more confidence. So often this path follows across several code cycles. We can't get there on this building, but we see how that's going to play out in the code, the next code, and then we'll get there. So we think through all these pieces together. This screen is an example of our brainstorming on a particular mechanical problem. We've been through every systems change in multifamily over the last few years: electric resistance heat in mild Bay Area climates, ventilation, exhaust layouts, centralized heat pump water heating. The next thing is coming is Appendix M of the plumbing code, which will change how we size water pipes. In our single family, we do HVAC and plumbing design work. We understand that systems layout is kind of like a living organism. It's not like just stuffing boxes in a moving truck. They have to relate to each other. I'll go back here. There's the integrated anatomy, like the main pump, you got to put it in the middle. The air systems need to be near the mouth. You can't stick them down in the thighs. So we work with the architects to help them understand this anatomy early on while this design is still flexible. So at this Lake Tahoe investment house, the HOA required this fairy tale castle kind of massing that made an inefficient spatial layout. But we made it work with 7 different duct systems and no soffits in the whole place. And then the client said, well, okay, can you eliminate the laterals too? So yes, we found a path, but because the architect and engineer were flexible. And that this custom home in Prunedale, the architect was able to right size it and orient spaces to the south and provide a generous overhang and shift program outdoors. And all this allowed a very compact, tiny HVAC plant in the red box and distribution in the yellow. And that was it. So good design fundamentals lead to very minimal HVAC. We found that 3D illustrations are good tools for communication, where there's a tight fit or some new detail. And our work here strives to speak clearly to tradespeople but also create more accountability in the construction drawings for those people. At the same time, we know that most tradespeople perhaps will never even see the drawings. So it's important we have significant fees allocated for the construction phase of the project, where we can talk to the trades and walk the job site with them and follow through. So yeah, finally, I'm a licensed architect myself, and I think in our consultancy, we've tried to create the kind of thing that I would have wanted when I was practicing and couldn't find people to work with. So thank you for looking at all this with me.
Just hit, oh, here we are. Okay. All right. Hello, everybody. So I started off actually with more of an intro about my company. So I'm the founder of Bright Green Strategies, where I started actually in Santa Cruz, moved up here because there's so much work up here. We have a little office in Berlin also. So I think what I saw that when I started the company in 2010 was coming more from the energy efficiency side of things and energy modeling, that the synergy that you can have between design and modeling early, and then following that all the way through construction, like Deanna was saying, you know, the follow through is really important. And I think that's probably what I'm going to emphasize the most tonight, because I'm also a HERS rater, which is another acronym for, I'm an energy rater. So I know how to do duct testing, blower door testing. These are things that I don't know how familiar you guys. Yeah, right.
Do the HERS rating.
Yeah, so maybe I should even go to the last slide, but I was almost going to bring my flow hood, you know. But that's to me like to how to connect the dots between all the work that you do, putting you know, time and energy into your design and specs, and actually have it, you know, be realized in the end. And so since we go out in the field as doing Greenpoint rated and LEED and doing the HERS rating, we go out in the field. So we see the job from design all through construction. So I think we're lucky in that way that we actually see the building getting built. But at the same time, when I see what goes on out in the field, then I'm like, oh my gosh, you know, like, you know, there's definitely a lot of issues, and that, you know, there's room for improvement between these two, you know, these aspects of the building, building process, right? So ideally, I said, you know, green building process would be like a seamless integration of design and construction. Reality, you know, we're not there yet, but this is something, you know, I think that I strive for. So it's just more about my company. You know, we support other green raters in Canada and also we're trying to do some work internationally. And as I see it, is we're providing a quality assurance process. So that's a way to hopefully, like I said, get construction to actually, you know, fulfill what your design vision is. So as a consultant, I think that's I think a very important role for us to fulfill, you know, for you, and then we can report back, oh, you know, these things, the things that we see out in the field, and hopefully help you to make it, you know, make it better the next round. So and then we also provide these support for we work with a lot of affordable housing developers that are pursuing different funding sources. So we also assist with that. Here's just some pictures, pretty pictures of affordable housing, market rate housing. And then, yeah, so let's see, I'm going to go to my last slide. So this is the kind of equipment that we use for testing. So in the lower left, that's a duct blaster. There's you know, a manometer. So I have everybody in my company trained in this building performance testing, so that when we go out in the field, we're looking at ways to improve things. I mean, there's just lots of simple things that, I mean, silly and simple things that could happen out there, like an exhaust fan might have a wad of tape that got stuck in the duct and then it doesn't exhaust, you know, and like all somebody had to do was just pull it out or, or not put it in there to begin with. So the only way you discover these things is actually through testing. So, and then this next code cycle, blower door testing is, I mean, a lot of people are trying to avoid these things, but it's really, there's not avoiding it for too much longer. But I think, if you get a chance to see how, like what we do in some of our projects is we'll come out and do if there's a mock-up unit, we'll come out and do the testing and show you what the test does. Like when you do a blower door test, for example, it's to me a good indication of how well the building is actually built, because if it's tight, if you get a really tight reading, that's an indication that the building is constructed well. So, and then if it's not, you'll be able to literally feel where all the leaks are coming in. So it's a good thing, I think, to get exposed to these kind of building performance tests. So this is something I feel like that will help to bridge that gap between your design and what happens out in construction. And then going back to, what is green energy? So as I've seen it, our perspective has shifted from like I said, from the 70s, where it was coming from the oil embargo and what's, looking at gas as our main energy source, to now realizing we have to dump that, and climate change is the reason why that we have to shift to these cleaner energy sources. The diagram on the bottom is something you can look, it's kind of fun to go to this CalISO website. That's actually shows you in real time what the grid is doing. And so our grid actually is, we have a lot of renewable energy supply actually already, which is the good news. So, but it's kind of cool to see, like, this will actually show you how much energy the whole state of California is using and how much is being supplied by renewable energy. So, there's, ways to, kind of expand our awareness as to, like what is actually going on in the bigger scheme of things, because our job for the most part is really at this micro level. We're looking at building construction and dealing with, contractors and subcontractors, where we get into the more of the nitty gritty of it. So it's kind of fun to also look at the bigger picture here of what's going on. So I mean, so as a consultant, I feel like, we have an important role to play and to help you, make your buildings successful, because I know as architects, I'm always amazed at how much you guys have to deal with, actually. I'm like, wow, there's a lot of people that you have to coordinate, and people as well as the building construction itself. And so I think, that's why we, always want to work together as a team. So, yeah. Anyway, so yeah, that's.
Any questions from the audience for the consultants before we go into the architects?
Oh, yes.
Hi, when you're doing blower door, are you doing it on large structures or just in the single family homes?
In large structures, we're doing it in multifamily buildings. I mean, I've done both. So single family and multifamily. When you do a multifamily building, it's really what's called a test of compartmentalization. So you're just seeing how tight that unit is to the adjacent unit. But there is a way to actually, like the guy I know in Canada knows how to do a blower door test of a whole multifamily building. So you get the actual skin of the building. It's a complicated setup, because you have to use multiple blower doors to be able to do this kind of testing. But but like I said, just once you start getting that data, you start seeing patterns and how, and start recognizing where the, kind of literally the holes are in the building. So, yeah.
Commissioning today is done mostly after the project is almost complete. Do you think it would be more helpful to start commissioning halfway through construction?
Yes, yeah, this is another way to think of, as a HERS rater, I think of myself as like a residential commissioning agent, so commissioning, yeah, I mean, we work with different commissioning, people, and so there's some people who do really good design reviews, actually, right up front, and which the mechanical engineers don't always like, because they're kind of, maybe picking apart their their design a little bit. But so there's that aspect where it's like a peer review right up front of the design, I think is value. I mean, I've seen a lot of value out of that, because they might see, oh, like if you size your tank a little differently, the overall cost, operational costs could be better. Things like this that matter to an owner. And then, so to me, commissioning should actually have a pretty rigorous design review process as part of it. And then, when you get through, to actually the functional testing part, like that can happen. Like when we go out there at frame, we're out there a lot actually during frame. Because we're checking insulation, we're checking air sealing, we check all this. The commissioning agents are, if they're doing mostly the big commercial systems, yeah, that's going to happen towards more the end of the project, so.
In residential, there are a lot of things to verify that will get covered, and then it'll be too late to do anything about it. So, right, rough inspections is the time to check envelope, check duct construction. All those things.
Seth, I think you're up.
Great. Hi, everyone. I'm Seth Dunn. I'm a founder of Praxis Architects and Integrative Design. And this is a newly launched firm this year that I saw as a need to really redefine the project delivery process and kind of add collaboration front and center into how we organize our team structures, how we approach stakeholders, construction teams. And so Praxis was kind of founded with the integrative design process, IDP, as a founding tenet. So, we're founded with the understanding that the most enduring building. And so if you don't have a loved building unless you actually bring the people into the process, bring stakeholders, get stakeholders involved, get a good facilitation process. And so we're founded with using a co-creative community process to really come at design decisions that are cost effective, cohesive, and that we're building social fabric and building community, building culture, while also delivering the building delivery. So you have your normal design process, you have your pre-design going through CA. The Praxis design process kind of adds two wings to that. So we have our discovery, and then we have our evolution after construction. So basically, design never ends. And in the discovery process, we kind of coalesce the community around a story of place, really focusing on essence, purpose, what makes a place special, and using that cohesiveness that we define in that discovery phase that to bring in through the design process, create community guilds and community groups that can build off tangent ideas, whatever people have passion in, that can feed back into the building design process. And then in the evolution phase, where we're continuously evolving, we're continuously improving through audits, evaluation, iteration of the building, because our clients don't stop, and they're always thinking about their next phase or their next iteration after the project is done. So in the discovery phase, you can think about guilds that might be related to the individual all the way going to the biosphere and thinking about ways that different places might be able to resource each other and be interconnected. And then in the evolution phase, also thinking about how we can create a sustained iterative development process that can spin off new ideas. You might have a conventional design team with architect and contractor not talking, the client. Everything's really a linear design process. In the integrative design process, you have a core team, you have your prime consultant team, the differentiating factor here is that not only do you have an architect, but you also have a facilitator. The architect's role as project manager can often be caught up in designing a project that's on time and on budget. And it's the facilitator's role to kind of peel out some of that collaboration from the architect and hold that that role slightly separately from the architect. So so a team can have both an architect and a facilitator on a larger project. On smaller projects, maybe that role is more combined. In the linear design process, you have different phases where you're bringing in different trades at different times, and then you're going through a VE process that kind of goes through a cost corrective analysis. Whereas in the integrative design process, you're actually doing VE from the very beginning, and you're actually moving through cost and constructability with different stakeholder groups oriented around community, water, materials, health, and everybody is brought in through facilitator to talk to each other. And so at Praxis, we've developed a roadmap of how we work through that facilitation process, how we set up meetings, and this is all customized per project. And if you haven't heard of the integrative design process, it's a LEED credit that's kind of been distilled down in LEED, but there's a whole ANSI structure around it that is pretty well developed. So we've taken that and we've used it as a process for facilitation. So yeah, I would say like the role of Praxis in green consulting is really how we bring in the team organization, because if you can rapidly iterate with the team, you'll come up with a lot better ideas than if you're just asking a team to deliver deliverables or having your energy model come in once and not ask any questions of it. I think there's a lot more role for cultural development and integrative project team delivery to deliver better results. Yeah.
All right. Awesome. Hi, everyone. I'm Katie Ackerley, Principal David Baker Architects. I'm going to bring a perspective from affordable housing, which is basically, the core of our practice. And, it's really a building. This is basically a story of someone who comes, as Brian sort of kicked us off with, a background in kind of green building and energy efficiency, working on a building type that people have very low expectations of. No one's asking for the next, deep green anything, these projects. And that's been really fascinating for me, actually, because it's been a great learning experience. At first, I was sort of like really challenged by that. And then I realized what an opportunity it was to look at what these metrics and these goals mean when you're working on a conventional project. So I'm going to try to sort of tell the story through a recent case study. The California Energy Commission put out a grant to sort of study this futuristic grid optimal affordable housing design model. And we were one of the teams selected to do this. And kind of going back to Dan's earliest point, this is all this, yeah, this all goes back to the challenge we have in California. All of this renewable energy on the grid really draws down our demand. I mean, our demand of other fuels on the grid very low while the sun's out. But then while the sun's starting to set and everybody comes home, there's a big ramp up, and that's when you get the dirty power plants online, and other types of failures. So I think, you know, the CEC is looking at this and looking at multifamily residential buildings. So all these people are coming home and they have a big afternoon peak, and thinking, okay, let's target those buildings to see, you know, how we could fundamentally design them differently to be more grid responsive. And hey, let's have that have, you know, multiplying benefits to low income families. Let's not leave low income communities out of the mix. So let's do this for affordable housing. Win, 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 win. Cool. So I'm putting this slide up to, again, underscore the point that what is green energy in today's environment? It is looking at all the tools in your toolkit and how best to integrate them, because these are dynamic factors that we're dealing with. I think, you know, Seth mentioned EUI, where and the sort of, you know, looking at zero has been a kind of idea that's captured our attention. That's really an annual picture of a building, right? That's looking at, and in our kind of own education in energy and environment and buildings and architecture, we have a good education about seasonality. I think the turn here is really kind of starting to understand our buildings on a kind of daily basis, to look at the shapes of behaviors that drive energy use from morning till night because of the cyclical nature of these resources. So the idea is you want to flatten that curve. So we tried to study that for this building in San Jose, which we were designing at the time, very conventionally financed, developed 6-story building in San Jose, 100% affordable, formerly homeless seniors. And I am going to skip to the end because this is a very difficult project complex to present entirely. But one of the things I want to I'm going to try to sort of draw out basic conclusions. One is that there are some incremental energy efficiency gains beyond what a kind of code building would have you do. But they are diminishing, and sort of going back to Dan's point, it's what we are being made to do now. We have to know how to do and know how to do well. It's not about throwing new tech at this problem. To give you a sense of when you sort of optimize all of those factors you saw in that kind of sequential graph slide, the load reduction, the peak shifting, the renewables, the efficiency, you go from graphs that look like this on a kind of typical near peak winter day and near peak summer day to a graph that looks like this. And so that's sort of the scale of reduction before you throw batteries at the problem that you can get through sort of basically architecture and equipment efficiency. A lot of this comes from the hot water, using hot water as a thermal battery to heat the water during the day and eliminate that peak when people are cooking and showering at the end of their day. Just drawing from your storage. When you throw solar into it, you get these, you know, peaks and valleys that are basically when the building is taking advantage of the sun to charge a battery to fulfill its just sort of, you know, self-consumed uses, and then where you're basically discharging the battery to the building is bringing that 4 to 9 p.m. peak to zero. So that was the whole goal of this challenge. In the end of the day, I think what we learned is that it's a worthwhile question, but from a societal perspective, it's not more affordable to throw these sort of basically big, expensive battery and microgrid systems at affordable housing. That's what would be required to hit that zero. Whereas that first level of reduction that you're able to achieve just from architecture alone is actually a pretty impressive win for the grid and also for your utility bills. If you take into account the resilience benefits of having that battery system in your building to weather power outages, if you're in a particular vulnerable place or the population you house is particularly vulnerable, we did our best to sort of see if we could quantify that in this sort of pre and post costs. And then you sort of like start to get to cost parity if you take into account the resilience benefit. So that's sort of where we left it is, you know, when we're having these discussions, it is so context specific. And it's very important to recognize and work from the needs of the people you're designing for, rather than these sort of preconceived goals about, you know, what each building needs to do to sort of do its part and be a good building. So, you know, we talked to residents about our plan. They were very, very polite and very sort of politely pointed out, like, but is it like, whose responsibility is this? When we talked about like resident demand management, sort of like strategies to encourage residents to curtail their use. So those are some key takeaways. And it's, again, there's not enough focus on doing better what we already know how to do when it comes to this kind of new wave. I also think when it comes to consultants, this drive and also the current code in almost mandating battery storage for this type of building, for multifamily buildings, is really premature in the sense that there are not mainstream tools that our consultants can use to help our clients really understand the economics and look at buildings in that kind of dynamic day-to-day way. You know, when the building's using energy, discharging to a battery, all of those dynamics are really, we used a tool basically for the study that is not in mainstream use. That's kind of a problem. Yeah, and in general, I think that the number one barrier when it comes to kind of merging a social imperative, right, with this energy imperative is that they are looked at as different issues. It's very hard to come at them the same way. You have the environmentalists, which lead with, this is probably like the slide in the other presentation that Brian saw. But like the real thing they're focused on is the energy and carbon, and these non-energy benefits are kind of the icing on the cake. And you have the housers that are the opposite. The homes are really what they're focused on, and they want to do what they can. And so, you know, a lot of this, and architects can do, I think, a lot towards seeing how we can kind of merge and integrate these kind of perspectives. And that is what I have.
Katie, has there been any talks within your company about changing the building types and get away from a wood structure and go to like an insulated concrete form that actually stores energy, disperses it at a slower rate to help you offset those peaks?
Yeah, that's really interesting. We actually, as a part of this project, did a whole kind of evaluation of life cycle carbon, both operational and embodied. And one of the things that we came away with is the way that we build housing right now is actually fine. It's from an embodied life cycle carbon perspective. For instance, if you were to use an insulated concrete form, the embodied carbon would, basically offset the sort of benefits from that. Just like a basic insulated wall is pretty good. They're cool products like this spray applied cork finishing material. So it's basically like stucco that has insulating properties. It's been commercialized in Italy for years as a kind of retrofit tool. Something like that really could unlock, the like reaping the benefits of that incremental increase in insulation, but without added cost and without added carbon. When you do the EPS foam on the girts and the cladding, the fiber cement cladding on top of that, that's a lot more cost. We don't find that we can afford that. for very, very small incremental benefit. But yes, we do want to increase the insulation value of, we do want our buildings to act more as batteries, but we need better materials to actually make that make sense in our construction market. So,
So the question was, what is renewable? Wood. Oh,
oh, wood is,
Wood is
I thought you said what?
wood is renewable.
Yeah,
Yes.
Yeah.
Yes.
But
yes, wood framing.
straw is even more renewable.
Oh,
No, if you could have materials that are rapidly renewable versus just renewable, then you know, it depends on what question are you trying to solve. You know, do you cut down the trees at 20 years, at 50 years, or what wood is renewable?
we did look at mass timber, and you have to get pretty tall before that ends up looking better than even like a podium, 6-story podium building, 8-story podium building.
Did you, you said that the project you were showing us was a senior housing? And is there, maybe I'm making some assumptions, but you were also talking about how, you know, the people come home, they go to work, they come home, and then I'm making assumptions that the seniors are not doing that because maybe the seniors are older and they're not working and their schedule is a little bit different. So I was just wondering if you looked at that at all.
It's a great question. So we had to make some educated guesses about the residential and hot water usage profiles given the population. We consulted the databases that were available and basically chose one that we thought was a kind of conservative. It showed a morning and an evening peaks just for the purposes of study. Yeah. But you're right. Seniors they're more active at home during the day. They spend less time away. Yeah.
Question for you. The data that you had on like showing the dramatic drop from the domestic hot water system, was that modeled? Was that like has it been built? Was there an evaluation done on like actuals? No. Okay, sad story. And also you mentioned using tools that are not mainstream. What tools is the office using that maybe other offices should be using?
Oh, our team. Oh, well, no, I don't know. And these guys should fill in too. For this project, we use a tool called Zendy, which I believe is still sort of incubated at RMI, who is one of our research team members. I'm not sure what other tools might be. That was even a couple years ago now. But at the time, it was really striking to me that we could be making these economic decisions on behalf of developers without giving them the tools to really look at it themselves.
This is not really following with the other questions that have been asked, but going back to the integrative process conversation, I guess what like frequency of meeting with team members do you think is most beneficial, and like how many different entities do you think should be in those meetings?
I think it's a complicated question because what we're trying to do is invite complexity into the process, where I think like often we're trying to our architects are trying to control inputs and making sure that we're not giving too much power to a community group, or letting in conversations get twisted and come in from left field. But when it comes to the MEP team and to the core team, I think you're really wanting to meet frequently to whatever's necessary to create an iterative discussion process, and not just like a deliverable that you don't get to ask questions of. For instance, an energy model is only as good as the questions you ask it. and it's the people in the room's job to really be like knowledgeable about the intricacies of how that energy model is actually created. You could have off-base assumptions for how many people that a room might have as an occupancy load that can drastically change an energy model. And if you're not asking the right questions of the energy model, you're going to, garbage in, garbage out. So, yeah.
So a general question to the panel. I mean, I'm always excited by these strategies. I'm not an architect. I work in energy efficiency. But how do you deal with the cost issue? Like, the more time spent or the different designs. Do you find it's able to be comparable? I mean, that is the argument, but.
For first costs. And I think it's how you structuring the team so that those first costs are either absorbed through on-bill energy efficiency upgrades or loan structures that can finance energy efficiency upgrades. Those are things that happen way before the architect is usually brought into a process that can have a drastic impact on what your what the scope is of the project in the first place.
I'd like to add that, yeah, the resiliency features, adapting to these cycles of energy, it does add cost above old buildings that don't do this. So we're kind of constantly in thinking of VE, and sometimes we're out ahead of the clients and the design team. Like, are you sure you want to do that? Because it's in the end, that's probably going to get cut out. So this often leads to some decisions through energy modeling that can go against green building dogma. Like, well, it'd be much cheaper if we can use electric resistance heat here and no heat pumps. And lo and behold, it doesn't make that much difference in the energy model. So maybe we go in that direction. So we're trying to shave wherever we can just to get things built. But I think Katie had a great point in that doing that in a smart way, you can get a lot of gains just by being economical about what you invest in, and then following through with it. And then you don't need the bells and whistles, which do add a bunch of costs, they add cost, but not as much value. So I want to point out lastly that you don't need to have PV and batteries on your building, on your site, in order to take advantage of this solar cycle. Like the whole grid is doing that behavior. That's what the duck curve is showing. So your building can still respond to that. You don't have to own all that extra equipment.
Yeah. I think that was the sort of big question is like, should all of that distributed energy equipment be hosted by affordable housing, which is already sort of playing this major infrastructure role? I will say that sort of setting aside kind of costly emerging technologies like a microgrid with central control that no one's actually invented yet, and like a massive battery. I do think in my experience that, value engineering decisions are as much emotional as economically rational, and they are based on, in a big complex project, it's not actually the hard math. And so I have learned how to pick my battles in trying to demonstrate value and advocate for certain measures, trying to back it up with what I know from practice, other projects we've worked on. And a lot of it is misconception. For example, getting this, like what Sharon was talking about, sort of a basic quality assurance commissioning scope in these buildings. It's not typically done. And a lot of that is because of a lot of sort of misconceptions and the ways that standards have really not been written in a way that serves these buildings very well. So a classic sort of LEED enhanced commissioning scope might be $100,000, but what actually makes sense for the building and just in like doing the job well, you know? So I worked with Sharon and a couple other consultants to sort of help me write the scope. It's like, you know, $50,000 or less. And so trying to make that, dialing it in, but also making the case in terms of quality assurance, LEED, you know, like talking about green building. It's also, I've been using that word a lot. What you're paying for is quality assurance. That's the value of getting a green certification, and trying to make the case on the back end of where you harvest that value. It's surprisingly hard to do, but I think a lot of it is this cultural kind of misconception about, and fear that like, if I'm going to be a LEED building or if I'm doing commissioning, it's these bells and whistles when it's not.
Yeah, I think, yeah, you can just say you're gonna get a better building in the end. I mean, that's really bottom line,
protecting your
what you're getting, what you pay. I mean, you're getting a better building. So, by doing all these things, but yeah, I think that unfortunately, yeah, like what's a first rater and what's a commissioning agent is still, you know, I mean, we've been around for, I hate to say, what, long time, for 30, 40 years, but it's still like, well, I guess that's why I'm here tonight, to say, okay, it shouldn't be a mystery anymore. So, these tools have been available for a long time, and, you know, the more you can get educated about it, or, you know, like I said, as consultants, we're happy to educate you and show you what you can learn from them, and hopefully help get that more integrated into the whole process.
Can I add one more thing about costs? I think with green building, there's probably more of a role for do-it-yourself than what we've acknowledged. And I think we should really encourage that. So some examples are, there's some nonprofits that are installing water heaters using volunteer labor. So you can go volunteer for this group, learn how to install water heaters, install them on some people's houses, and then they'll do yours. And so we're kind of spreading out the costs and educating people at the same time. And then with natural building, it's common to have a work party to avail advantage of people who want to learn and offer their labor, but you're educating at the same time about all these techniques. So I think for smaller projects, we can expand on these ideas and do more engagement of everyone to lower costs.
I just wanted to ask, when it comes to like green building, I guess you guys talked a lot about trying to like think of other methods and maybe going back to older methods of trying to maybe focus on passive heating and cooling methods. And so to what extent do you think is it more important to focus on making our systems more efficient as opposed to maybe going back to other construction methods or material you use? Like, for example, I'm a recent Berkeley grad, and I guess I took a few studios on like mud architecture and like mud as a construction material that, you know, is no longer really used, but it works really well when it comes to like thermal mass and like those just like more passive, I guess, and like energy efficient heating and cooling methods.
I love mud. I love clay plasters. You know, clay has a natural ability to regulate humidity in the house, and so if you have a clay on interior walls, it's doing a lot to improve client comfort and client benefits. And yeah, I think the first step is always passive first. The first step is always proper orientation, proper air sealing, good windows, and got the other passive house principle, the building envelope. But yeah, so focus there, and then add in appropriate technology, right? The term appropriate technology comes from like technology that people can do, like manipulate themselves and actually fix the crack in your wall. Right? You shouldn't have to rely on an expert to come in. It's really expensive to do on your own house. If you can fix your things yourself, it's way cheaper. So using the right technology for the right application.
I hope this is direct enough. Answer to your question, I think what your question brings up to me is just how much the architecture profession lost or gave away, is moved into the modern era in terms of just what is under our purview, what we're responsible for. We used to sort of have so much more embodied understanding of light and heat and material and that sort of thermodynamics and air as well. So I taught building energy for a number of years and in a very limited time frame where we really couldn't impart on the students sort of equations and modeling tools in any way that it was ever going to stick. And so I became a believer in trying to get architects to go back into their bodies and really remind themselves that the things that are second nature to us, because they're so important, like the little thermal adjustments we make that we do without thinking, the way we adjust things in our environment, how sensitive we are to light and odors and acoustics and smell. And thermal conditions. Those are, that's how important they are. The fact that that they're unconscious. So I think there's a way to do that without being, getting a PhD, essentially. Know where the sun is.
I think some of these ideas of going back to the basics is interesting. There's a lot of talk about it, but like in urban settings, sun orientation, you're caught on the grid, right? And you're have blind wells on the sides. So and the sun is the big one, right? Of these fundamentals that we're talking about. How do you deal with that? You're not going to make the building out of mud in downtown San Francisco. There's some talk about wood being renewable, which is great. Fires, burns, and you have to throw it away. You get to a certain height and yes, mass timber, you can do it up to 22 stories or whatever it is. But you're covering 1/3 of it. What size of height you're at. Yeah. Is it really practical? Fundamentally, maybe it's not most appropriate for things.
But that makes me want to say it's kind of not like the high tech products that we need to solve that. We need more low tech products that do that well. Like thinking about how do you do the best passive natural downtown housing in San Francisco? Right, okay, it's a wood frame. You can also fire protect that. You can build it up to so many stories. And then just stop. That's plenty of stories, and then work on the next property. But and then can you make a facade passive and still make this thing affordable? Pencil out. So we've never gotten exterior overhangs or fins or anything on a building. They always get cut. It's just too costly for what it does, what it provides. But maybe there's a way to do white blinds that are outside the window, so you can reflect the heat when you don't want it. And then you could do a simple system in the San Francisco building with no cooling because you can reject all that unwanted sun. But that blind product, maybe there's not a good product out there that would allow like the correct window opening and deal with the wind, or maybe there is and it's a European product, but that's not a high-tech product. It just needs to be built for this market and robust and affordable. So that's the kind of innovation I feel like we need. So appropriate technology. So one of the definitions I've heard of appropriate technology is it's an open technology. It doesn't lock you into something proprietary that you don't know how to fix. It's like, okay, anybody can come and adjust the screwdriver and fix that blind. So that'd be a good example.
Yeah, it's a loading order, right? That, we would never put our blinders on to site relationships and just put a bunch of bar buildings facing south when there's real community adjacencies, topography, things that you're dealing with. And that is a part of what we're talking about as well. But I think like Dan said, I mean, the building that comes to mind is the one that, situated on Eddy and Taylor in the middle of the Tenderloin, polluted air, noisy streets, southwest building. And, occupying that corner is the only way to kind of build housing on that site. We did get away with sunshades on that project and tuned window to wall ratio and window sill height. The head height's important for daylight, but the sill height is what can be raised, in part because the client was adamant not to add the cost of air conditioning into that building, in a building where basically people couldn't open their windows because of exterior conditions. So we did everything possible we could. We got the ceiling fans in, we got the duotone sunshades to have white on the inside, so not to attenuate daylight too much. And we made them kind of wire for the possibility of adding evaporative cooling to the ventilation stream, you know, when we knew that inevitably it was gonna, that building, those units are gonna overheat. That's a lot of tools to throw at a problem before getting, you know, super high tech. It's just being thoughtful gets you very far. I think that's the lesson.
There is a building on the market that does have vertical shades on the exterior side of the
Yeah,
building. that
Stanley.
you open and close. During the day.
Yeah, that's true. The question from the audience or comment was talking about Stanley Sawitz's building. He did two of them, right? That have the screens that move. One on 8 Octavia and then one on Howard. 123 Howard. 1234 Howard. Yeah, I don't know if they've gotten stuck or not, but yeah, interesting idea. All right, so we're all gathered here. We have architects, consultants. How do you guys see the best role and relationship of them, of the team? Seth, you've proposed some kind of tweaks on the traditional way of integrating teams, the facilitator. I don't know how that role would fit into this, but just in general, what have you seen successes of these relationships, everyone?
Yeah, well, I keep going on that. I think bringing in the consultants as early in on the project as possible and making sure that that you're setting up a relationship where everybody is going to hear each other's points. Often if it's just the architect talking to the mechanical engineer and then talking to the electrical engineer, you're not getting that synergy. The other thing is, you know, the mechanical engineer being your energy modeler is something that I've had to historically deal with, and I'm wondering what other people think about that, separating that out or having that together, and how do you actually have multiple sets of eyes on a mechanical system, because often I'm not sure there's that enough peer review there.
Yeah, I mean, I think energy modeling early and often is important. I mean, my bias is, I mean, we do energy modeling. We're not mechanical engineers, but we know how to work with the mechanical engineers to help make these design decisions. So I think it's just, you know, if everybody's a team player, right, that the modeler's job is to say, to take, okay, these are the 4 mechanical options that you want to look at. And, you know, it takes time to, and it's not just mechanical, it's like all the moving parts, right? The building envelope, shading, maybe if there's some thermal comfort aspect that needs to be looked at. I think, I mean, as an energy modeler, you know, we know how to use the tool well. We have to understand mechanical systems. And so I think that's the value we bring. You know, that said, there definitely are mechanical engineers that we know that are good at modeling, but I think they like to, at least in my experience, it's been, they like to use it up to a certain point, maybe for figuring certain things out. And then, you know, when it gets down to, okay, like finishing it out and getting it ready for permit, they're happy for us to take it over or take it on. So, yeah, so I think, you know, again, it's just, you know, once, because we're mostly working in multifamily buildings, and there's always a design team, you know, with a lot of us know each other, you know, for a while, and we know, you know, kind of what the options are. And then as new things crop up to look at, maybe like there's this new, what was it, God, it was like it looks like I think it's called a VTEC. It has an integrated ERV. But it's like a PTAC that's like vertical, but it has an integrated ERV, and we're like, oh my God, how do we like do, you know, so like that as a modeler, it's our job to figure out, okay, how to model it. And then also like, or how do we duct test this? How do we, you know, like, so this is the kind of thing that I know that we do. We're like, when we see something, we're trying to figure out, okay, how to present something that maybe, you know, or somebody brings this to the table and we're like, okay, how does this make sense for the project and for what we're trying to do? If you have low cooling loads, which generally we have, but you know, but there's definitely, like when you have the west facing, you know, situation, you're going to have cooling problems. So having, you know, I guess like I said, since we're mostly experienced in our housing sector, I think that's the value that we bring to the job. And but depending on the mechanical engineers and the electrical engineers, you know, we always try to leave room for, you know, that back and forth conversation.
I think doing the same thing with the same people is really helpful. But that being said, as someone who does the same thing with the same people a lot, you also have to discipline yourself because things change to ask questions anew. So for example, so there's a couple of things I would say to set up a good process. One is you have to get a pretty clear idea of what the goals and opportunities of the project are before you procure your consultants. Because once your consultants are in the team, the capacity on the team is what you have. So if a goal comes around later that like, oh, I really, you know, it'd be great to look at, you know, water recycling, and you don't have a team member that can look at that, that ship has sailed. Other thing we do is we write our consultant RFPs, requests for proposals, with some sort of stealth scope items that are important to us. The owner can always opt out of them, but it's easier to opt out than to add them later. So that is how, and Sharon and her staff are very appreciative of this. We get insulation inspection, blower door testing, just baseline on all of our projects. No one's ever taken out the insulation inspection, blower door testing rarely, and commissioning, as I mentioned before, this sort of new scope. It's like, it's in, you can choose to take it out. When we start the project, I try to get all of our project architects to recognize the kickoff meeting with the full team. This is usually after a lot of the design has been done, a lot of the sort of vision of the project has been established, to really get that clear pitch of what the project purpose is, like the bigger idea, and onboard the whole team onto that big idea. That is probably second nature to a lot of projects. For the projects we do, they're like pretty conventional. Again, no one's expecting anything but a bunch of apartments. It's so important because it completely sets the tone. I had a project that was engaged in a living building challenge, kind of a thought experiment, for lack of a better word. And when we kicked off the project with this, like, we're going to like examine living building challenge as we design this project, the structural engineer pulled me over afterwards, was like, this is great, because internally we're looking at like how to reduce our embodied carbon, you know, using like, you know, structural methods. And the reason that that's a funny story is that embodied carbon wasn't a part of the living building challenge at that time. It was just a tone that was set that got them excited. And the third thing about setting the tone is really trying to establish and break that that pattern of architect gives consultant backgrounds or, you know, direction, and the consultant follows suit. Never react. They never sort of bring, what about this? Like a more integrated, even if you don't have a sort of formal integrated design process. So you can set the tone of like, bring your ideas to the table, and that can help. That's it.
Let's see. Here. I used to work for a bigger architecture firm, and we did institutional projects, or institutional clients. And we would often get engineers on the project who would say, okay, what's the envelope? So I can put it in my calculations. Tell me what it is. So it's very one-way flow of information. But they had nothing to bring to the conversation about, well, what should the envelope be in order for me to right size my systems or make them smaller? Or if you architects would just give me this glass, then we could do this with the mechanical. So those kinds of engineers were a little disappointing to work with in that role as an architect. So what I like about being an energy consultant is we can kind of knit things together. We know we can we have that board with all the trade-offs between this and that, that we're playing with, and we're constantly giving this feedback to the team. And then, teams work efficiently when it's the same consultant, same architect. But then as the energy consultant, we work on so many projects. I kind of see us as like a pollinator, where we can take, well, here's what this team's doing really well, and we can suggest these things to this other team where they might never work with those people, so they wouldn't know. So that's a lot of fun.
Steve works his clients against each other.
Not against each other.
Well, LMS is doing this. Have you ever thought about that?
So we had a prep call and lots of engagement in email. It seems like CA, and you've talked about it a little bit, Sharon. Anything else you want to elaborate on that? Just how to solve some of those issues that may come up in the field? How do you go from SD, schematic design, and you design things through CDs, and maybe everything is tight, then what happens? And is it education? Is it really having a conversation with contractors?
Yeah.
Is it getting the ownership on board? Is it educating architects more? Like how do we actually get this more tests?
Right, how do we get this?
How do we get this to
train
work?
rolling?
'Cause again, you propose that
Yeah.
it's a simple thing,
Yeah, but it's like I think all those things, because the architect, the owner for sure has to be on board. And when we're out in the field, we definitely try to have really good rapport with the contractor, with all the construction people that, because and especially like if you're working in San Francisco, where they actually enforce things, they may not enforce things totally correctly, but they are asking for things that other building departments don't. And so we're in a situation right now where we're at the end of the job and the building department's asking for all this stuff. And so we're like, oh boy, it's not good to be at the end of a job and then they want a blower door test, for example. You don't, because that's something, again, like we want to see how the building's constructed during rough to make sure that at the end, you're going to pass the blower door test, So yeah, so it is it's a little hairy for us, to be honest, when you get into these things. So education, like we all are aware, like there's actually going to be a pause on the energy code for a while, which I think is a good thing. The 2025 energy code will go into effect January 1st, but it will give us time, I think, to get better enforcement. Enforcement's always, forever been an issue. And because the building departments don't enforce the code, then the contractors can be lazy about these things. And so, so that's been an issue forever, and so maybe if that were to change, or they know the owner is going to want the commissioning, the testing, then they know they have to do a better job. Like the fact that they know when we're going to come out and do duct testing, and we don't tell, it's a random test. We don't tell you what units you're going to test. That puts them on their toes, right? And that's what you want to do. You want to keep them like, okay, yeah. So that way they know they have to do a good job, or a better job on everything, not just, the units that we're gonna test. So it's definitely, we're still a work in progress. And, but so hopefully, yeah, education and keeping that rapport and communication and getting to know, people that do building performance testing, and then having all of you become, proponents of it would be helpful.
Yeah, I've had clients, residential clients say, after they've moved into the house, call up a year later and say, you'll never believe, like they installed this system here and that system there, and they were reversed and the flows were terrible, and I've never had good air in here. And why didn't you propose to me to come out to the site during construction and check on all that? Why didn't you put that into your scope? Because that would have saved like the $10,000 I'm spending right now to sort this all out. So that was a good pitch that I give to people now. It's like, just pay for the site visit and we can save you all this time and money later on when stuff is not working.
I mean, I love all these because they're very simple, ultimately, right? It's
Yeah.
like do the job right, take the ducts correctly, put the
Right.
mastic around it, make sure the system's right. It's like overall. they're not
It's all
complicated
things they
things.
should be doing, but nobody checks that their work. So then, you know, I mean, we've had a job where they just turn on the boiler. They didn't even check what temperature it was at. And I'm like, oh my God, like.
So many ways we're designing these one-off structures over and over again, reinventing the wheel. And I'm curious how prefab and modular might affect the way that we're delivering tighter buildings or tighter projects. And also the delivery formats, you know, design build, or ways where we align incentive structures, and instead of having split incentives that can get the contractor to be on the same team. Yeah.
You guys have had some modular experience. I think you guys do, which we'll talk about maybe next month. But any insight out of it?
Well, I mean, I can speak to the kind of volumetric modular that we've done for, you know, mid-rise multifamily housing, which it's like that Anna Karenina principle, all happy families are alike, all unhappy families are unhappy in their own way. But all well-functioning modular projects are the same, right? They work great, they fulfill the promise of you know, especially cost savings from a really contracted construction schedule. But you've also put all your eggs in one basket, and one thing can go wrong and basically blow that up. That happens all the time. There are also challenges with, I mean, not from a performance standpoint. I think the quality assurance piece in the factory, the promise is really good. The factory needs to be oriented that way. And that's not true of a lot of factories, but a lot of it is. But just from the delivery, just from the pure sort of like how it's going to really take off in the marketplace, it needs to be a bit more resilient to all sorts of disruption. And it hasn't really shown that yet. But that's like the big volumetric modular projects. There's all sorts of industrialized construction methods that could be brought to bear. I hope to be working on a project that is, you know, looking at attic insulation, air sealing with robot technology, you know, robots going around and doing all the attic insulation. And there's, you know, prefab wall systems, there's prefab sort of casework components that pull all of these sort of components, like a kitchen that has the intersection of all these trades. If you can just deliver that kitchen as like a prefabricated component, that could really hold promise. So it's not all about building the boxes in the factory and stacking them.
All right, so just a last question. I'm personally interested in just how architecture is affected by these green technologies or green. We talked about some of our green energy, we talked about some of it, seeing some LMS buildings, or the solar trellis becomes this piece of architecture, which is pretty excellent. I'm also interested in this community. Just like, how does green energy affect communities? And Katie, you kind of talked about that, the senior project. You don't talk about either one of those, but any closing words of wisdom or things to inspire us on? I think both of those things are pretty inspiring. I don't know how to solve them all, but please, yeah.
I'll just go first by saying I really appreciate all the inspiring images Dan kicked us off with, because I think ultimately we have to be excited about the possibilities. And it always helps to look at other work.
I guess I'm always happy when I see the project at the end and see the people moving in, especially in affordable housing. That, you know, the first picture I have of the senior housing, where people are, you know, they have a social network now rather than living in isolation, is really important for as we get older, right? And for families too, to have these social networks. So it's always a pleasure for me to see, you know, the people moving in and going to the open houses at the when they finish the project, to meet the people that are moving in. They really appreciate. And affordable housing is not cheap housing, actually. It's actually very nice, so.
Maybe I'll add that the low-tech and natural material projects, we can increasingly incorporate that into small buildings and single family and kind of work up from there. But it's not just the materials. I mentioned before, when something becomes simpler, then more people are able to engage with it. And so you can just get, oh, friends and neighbors, come on over, like do this part of my house construction and we'll have a party. So it's not just the labor savings, but you're engaging the community with these kinds of mechanisms too. And I've seen that in the very small scale. So it'd be nice to see how we can kind of grow that into bigger buildings.
I'd say it touches the community in a way that, you know, quality buildings they're quieter, you're breathing healthier air, you're you know, just having a quality construction with natural materials feels like with bio-based materials it's doing so much more than just carbon or energy. You're buying quality.
I want to thank all of you. It is wonderful. I think it was a good discussion. Thank you all for your questions. Maybe next time you guys just do it nice, quiet. So next month, next month we're talking about structural engineers and architects. So should be another great program. So please join us on August 21st. And then lastly, if you enjoyed it or didn't enjoy it, please give us your feedback on the event so we can continue to improve or continue to do the same thing. Thank you all.
All right.
Appreciate it.
Thanks, Brian.